Okay, for the next one, you're looking for when is this function decreasing? And it gives you your derivative already, thank goodness. So this is the ugly derivative. Basically, you need to evaluate your derivative and find when it's positive, when it's negative. The top is absolute value, so it's always positive. The bottom is negative, negative, positive, positive. So overall negative, negative, positive, positive. So it looks like it's decreasing from negative infinity to 2. For what values of x is the function increasing? Take the derivative, make your sign chart. Derivative is a little ugly. Just make sure that you're using the product rule. So that guy gets kicked out front. One of the things you want to look for is this is e to the negative x. So when you take that derivative, make sure that you have e to the negative x, because that's the original derivative, and then you got to use the chain rule to kick that guy out to be negative. If not, you're going to mess up your factoring. I decided to go ahead and pull that negative out front. I didn't like the negative x squared, so I factored out the negative to make the factoring a little bit easier. So your two critical points you're evaluating for are negative 1 and 3. And you'll see that between negative 1 and 3, that's the only place that function actually is increasing. You want to see where it changes concavity at. So this is the graph of the function. There's a few different ways that you can kind of look at it. Okay, so there's a few different ways you can kind of tackle this piece. What I decided to do, I went into my calculator. In y1, I put the original function. In y2, I took the derivative of the original function. This was math 8. When you're wanting to graph a derivative, for an 83, it's y1 and then x. And then x. So usually if we were evaluating the derivative at a specific point, instead of the second x, we would put a number n. So this is the first derivative. We need a change in concavity. A change in concavity is going to be an x-intercept of your second derivative. So I went ahead and I did math 8 again. And this time I took the derivative of the y2 and then x and x. I changed my window. I looked at what my x values were that they gave me, and most of them were negative, so I went negative 3 to 1. Changed my y scale so I could kind of see just that specific part. So this is going to be my x-intercept that I'm looking for. So my left bound probably around negative 2. My right bound will do negative 1.5. Somewhere in that region. And there it is, negative 1.89, which is D. Derivative of f is this guy. Which of the following values of x do you have a relative maximum value? Basically, I took that guy, graphed it. What you're looking for a relative max, and this one I'm actually not going to graph, it's a little bit easier, so because you already have your derivative. What you're looking for a relative max on your original function is going from increasing to decreasing, which means you're looking on this guy from it to go above to below. So kind of find where that happens on your derivative. You're looking for the x-intercept again. Make sure it's the x-intercept where it goes from increasing to decreasing, and that should happen at 0.91. This is technically like the integral stuff that we did in chapter 6. So when you're looking at this one, keep that in mind as you're going through it. But basically, when it tells you that you have a graph of f shown up here, this is your derivative. So you can go through the same process that you did before. So this is going to be increasing. This is going to be decreasing right here. You're going to do concave up on your original. This is concave down all the way to here, and then again concave up. So what I kind of did, if you looked at my work, is kind of broke it up and just kind of got a sketch from there. Now obviously mine is a little off from here, and so it kind of just, I made it decrease too quickly, but E is definitely the closest one. So I went from A to 0, so A to 0, kind of where that concavity change looked like it was happening, and then 0 to B, that was an intercept, and then from B to about right here, and then B over to C. This is a graph of a function f, and it's asking where is the function undefined. It tells you have a horizontal tangent at 1 and 3. It tells you have a vertical tangent at 2. And then you also have a discontinuity hanging out right here. Discontinuity vertical tangent, both of those imply it cannot be differentiable. Having a horizontal tangent is a good thing. That's what we want to see. So B would be your only option. This is a tough one. I think this was on your semester exam review packet as well. So this is the way that I kind of pieced it together is you have a whole bunch of F's and F primes and F double primes. So the first thing is F of 1 is equal to 0, and that was kind of my starting point. Then I did F prime at 1, which is your slope, so that was going to be greater than 0. That's a positive slope. And then the next thing I looked at was concavity, which is your double prime. So concavity at 1 is going to be concave down, which means that is less than 0. What I kind of pieced together was, okay, this guy is 0, so it's my medium, my middle one, I should say. This guy is negative, so this guy is positive. So this has to be less than the derivative, but this guy has to be greater than the second derivative. And I think that matched D. Although I wrote B. Oh, it is D. Sorry, I was looking at the wrong one. Inflection points. It gave you your second derivative. Go ahead and solve for each of those x's. Do your sign chart. You're looking for a change, and it only happens in between at -1 and at 0. At 2, it remains positive. Increasing. This is where you have to take just the first derivative. I'm sorry. Solve for x, so 2x equals 0, it happens at x equals 0. 2x equals -1, that does not exist. When you take that square root, you can't take the square root of a negative, you'd have an imaginary solution. We don't put imaginary stuff on the real number line. And then I just evaluated it to make sure that you had a change, and you do. Okay, so this is a graph of f, and you're looking for a graph of the derivative. So you kind of piece it together. This is concave up, this portion's concave down, concave up, this is increasing, switches to decreasing, switches to increasing. So you kind of just have to be careful. Since this is always increasing, this portion of the graph needs to be above. This guy is always decreasing from 0 over to infinity, so it has to be below. You do have a 0 or horizontal tangent hanging out at x equals 0. That guy right here. So that's why you want it to be 0 on your graph as well. And so when you kind of look at your pictures, I think the only one that he actually matches is hanging out at A. This was a nice one. So these are 3 different derivatives or 3 different functions. And you want to know which one has a relative max. So a max means that you have a function that went from increasing to decreasing, positive to negative, above to below, so it has to go from above the x-axis to below, and the only place that happens, this guy stays above, this guy goes from below to above, but that would be a local min, this guy stays above the entire time, the only one that has that is f. This is your derivative, how many critical values, graph it, and make sure that you do, on the interval 0 to 10, count how many x-intercepts that you have. You should have 3. This was a fun one. So g is differentiable function, but g is always negative. So no matter what you put in, g is always going to have a negative value. So he's hanging out maybe something like this. He's just always negative. It wants to know which of the following are true. I read all of these. It looked like it was talking about mins and maxes, so that meant that I had to take my derivative. So I had my derivative given to me. This is my derivative. This guy was always negative. So basically I needed to solve for my zeros, which I did, and evaluate. So for this guy, positive, negative, positive was his sign chart. Negative, 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 those correspond to your g's. And the idea is this guy goes from decreasing to increasing, that's a min, and then he's increasing to decreasing, that's a max. Relative max at -2, nope. Relative minimum at -2, yes, and maximum at 2, looks good. This is saying both minimums, both maximums, and this one's saying you can't determine anything, which is false, so it has to be B.